Hello everyone, welcome back. In this lesson, we're going to continue to talk about functions, and this time we're going to introduce the concept of adding parameters to a function. So I've already started here with some boilerplate code, and just like with every example, we need something to work with before we can talk about the function part. So in this example, what we're going to do is we're going to write a little function that's going to draw a polygon. Okay, so what do I mean by that? Well, let's take a look at the reference. One thing that you may notice if you look at the shapes here, okay, is there isn't a function that will allow you to draw, let's say, like a pentagon or a hexagon or an octagon or so forth. There's some arbitrary number of side, regular polygon. So we're going to define that that function. Okay, we're going to call it polygon. And it's going to be a flexible function, so it's going to be able to draw a shape with a different number of sides. Okay, so not just a square, a triangle, or a pentagon, but any number of sides. So that function doesn't exist, and in order to be able to create this, we are going to use the vertex drawing functions. Okay, so vertices are basically points, right, on a shape. And with the beginShape function, what we can do is we can define shapes, custom shapes that we create, as long as we know the coordinates of all the points that make up that shape. Okay, so for example, this beginShape here is putting down the four corners of a square, okay, using four vertices, so using the vertex function. So in between beginShape and endShape, you can have any number of vertex calls, right? Vertex points. And what those do is basically lay down the points for a particular shape. And beginShape has different kind of modes that it can function in. It can draw closed shapes like this. It can draw it as just simple corners like points. It can interpret the vertices as lines, right? So this is one line, this is another line, and so forth. So there's a few different modes here. We're not going to get into all of these. We're just gonna draw like the basic shape here, basic closed shape, and we're gonna write a little bit of code that's going to calculate the points for an arbitrary polygon. Okay? Now, in order to do, so how do we do this? Well, we have to talk a little bit about trigonometry and math. And before you run away screaming in fear, don't worry, it's going to be fairly basic. And even if you don't fully understand the math behind it, you can still apply it just by translating the formula into code, as I'm going to show you how to do. And this is one that pays off to really learn a little bit, the equation for points around a circle. Okay? So this is a polygon, okay, that we're going to create a function that can draw these types of shapes. It has 5 corners here, and what we need to do is calculate the coordinates of every point around that shape, so we can draw it as a shape using beginShape, endShape, and vertex. So in order to do that, what we need is we need to be able to calculate coordinates of points around a circle. Okay? We're going to treat the center of our shape as the 0, 0 point, so somewhere around here, and we're going to calculate the coordinate of each of the corners using the equation for a point around a circle. And each of the corner is basically going to be a different angle, right, around the circle over here. So this is where trigonometry becomes really useful. So this is the trigonometric functions for a point around a circle. Okay? So if we have a circle that its center is 0, 0, like this one, okay? We're going to assume a radius of 1, because this function works for the unit circle, which is a circle that has a radius of 1. And if we know the angle that we're interested in, right, we know the angle around the circle, and we want to know what is the xy coordinate of the point along that circle shape, we can use this formula up here to figure it out. We take the cosine of the angle, that becomes our x coordinate, and then the sine of the angle becomes the y coordinate. Okay? So we know the angle, we know cosine and sine. Now we don't have to know how to calculate these because there's already a cosine and sine function inside P5. Okay? So all we have to remember is that cosine is x, sine is y. Okay? If you pass it the same angle, this will give you a coordinate of a point around this particular circle. So we're going to be able to use this idea to calculate with different angles, right, the coordinate of these corners of our shape. Last thing to note as well is that the assumption is that the angles are in radians. Remember, we talked about angles in the previous video. Radians are just another unit of angles. So radians around a circle go from 0 to 2 times the number pi, okay, or 2 pi. This is the same as going from 0 to 360 degrees. So same quantity, same idea, just different units, just like centimeters and inches. So cosine is x, sine is y. Let's apply that into some P5.js code, shall we? All right. Okay, so before we create a function, we're going to start just by figuring out, how to calculate a point around a circle, and then how to use that information to derive a number of points for our shape. So first, let's just test the idea of calculating point around a circle. I'm going to start by translating the origin, which is normally up here. I'm going to translate it into the center of the window, because this whole equation for point on a circle assumes that the center of the circle is the 0, 0 point. Okay? So I'm going to move that 0, 0 point into the middle over here. So first we need an angle. Okay, so we're going to create an angle. We're going to map the mouse cursor here to an angle just for testing. Okay, let's call this angle. We're going to map mouse x, which goes from 0 to width. We're going to map it to an angle between 0 and 2 times the number pi. In P5, we can represent that using the 2 pi constant. Okay, this is a built-in variable, all caps with an underscore. This represents 2 times the number pi. Okay? So this is just going to give me an angle from 0, right, to full 2 pi over here. And we're going to use that to kind of move a point around a circle. So first we need to calculate the x coordinate. And we saw in our little drawing over here, x is the cosine of the angle. Okay? So we'll say x equals cosine of angle. And then y equals sine of the angle. And then we're going to draw, let's say, a little circle at xy with just a small diameter here. So we can see it's moving a little bit, right? But it's not moving very much. And the reason for that is because the diameter of our circle that we're calculating here assumes a radius of 1. Okay. If we wanted to make this a bigger circle, all we have to do is multiply these coordinates by the radius. Okay, so for example, if I wanted this to be radius of, let's say, 100, right? I could multiply these by the radius that I want. Oh, typo. Cool. So now we have a shape that basically can go around a circle. Okay, and we can see that. Let's make it a little bit bigger. It's so tiny, it's hard to see. So now I start at 0 over here, right? And you can see as my map creates a different angle, I'm going all around the circle all the way back to the beginning. Okay? And we're calculating the xy coordinates along the path using the point on the circle equation. Okay? So cosine is the x coordinate, sine is the y coordinate. That's all we have to really remember. And then we multiply that by the radius to scale our circle as needed. Okay? So let's take that idea and calculate a number of points. So we're going to start with 5. 5 points around the circle to create a pentagon. Okay, so how would we create 5 values? Well, instead of mapping the angle, we're going to write a for loop. I'm going to say, let's write a for loop that repeats 5 times. Okay, for loop that repeats 5 times. Indent this in. And then this angle here, instead of mapping the mouse cursor, we're going to map the mouse counter, which goes from 0 to 4 in this case. And then we're going to keep mapping this between 0 to 2 pi. Okay. So if we do that, the last one goes right back to the beginning. So we do want to use 5 here. We're going to go 1 more. Yeah, same thing as when we did that clock example. We know that the number doesn't actually go to 5, right? It stops at 4, but this is what we want, because if we go all the way back to the beginning, we don't want that. So this is now first 1, 2, 3, 0, 1, 2, 3, 4 up here. Okay, So that works. So this gives us, and let's make the radius a little bit bigger too, so we can see a little bit better. So this gives us the 5 points of our shape, right? So they're just basically 5 points around a circle. So now let's connect them using the begin and end shape functions, and let's draw a vertex at each of these locations. Okay, so instead of drawing a circle, we are going to say begin shape before our for loop, end shape at the end of the for loop, and then inside the for loop, instead of drawing a little circle, we're going to draw a vertex at xy. So vertex is just a point in the shape. And now we get this shape over here. And if we turn the background to gray instead of black, we'll see that the outline, right, it remains open, this shape here. So when you use begin shape and end shape, this is fine. You know, maybe that's what you want. It will connect the first point to the next, right, to the next, to the next, to the next. And then we end over here. If we wanted to close the shape back to the beginning in end shape, we say close as a parameter. And now it's closing the shape over here. All right. So now we have a little bit of code that can draw a pentagon in this case. Okay? If we wanted to draw a square, let's say, we would put 4 here. If we wanted to draw an hexagon, we would put 6. So let's define a variable here called number of sides. Okay, number of sides. And this variable we're going to use to define for loop and our map. And now we can experiment with different shapes. Okay, now I have 6 sides. I can have 3 sides, right? I get a triangle. I can have 12 sides, right? I don't know what that's called, but it's got lots of different sizes. Okay? So we've written a little bit of code that is able to draw some arbitrary regular polygon. Okay? That didn't exist before in P5. Now we've figured out how to program this. Having done all this preamble, now it's time to finally talk about functions. Now, one thing we could do is we could say, let's take this code that we've created here, right? And let's package it up as a function so that in the future or in this program, whenever we want to draw a polygon, we can call the function, okay? We can say draw polygon. So let's grab all of this code over here. I'm going to cut it out. And I'm going to write a function called polygon. Put it in here. All right. I'm going to put my little line of comment here so we can see a little bit better where things begin and end. And then in draw, of course, if I hit play, right, remember when we define a function, just like with events, this code doesn't run until it's called upon. Okay, so we have to now go and draw and call our code using polygon. All right. So this works. But it is very limited. Okay, as you can imagine, this polygon can only ever draw a 5-shape polygon, right? That has a radius of 300, as we see over here. Let's move the radius up to the beginning here, just so things are a little bit more clear. It can only ever draw this shape because we don't have any way to specify function parameters. Okay? So obviously, this function would be a lot more useful if it behaved like circle, for example, right? So when I draw a circle in P5, I provide some parameters. I say I get an X, a Y, and a diameter. So I can use the same circle function that knows how to draw a circle. I can reuse it to draw different size circles and in different locations. So parameters are very useful because it allows us to kind of input some values before we run the code that we packaged into a function, and have that same code do slightly different things every time based on the inputs, right? So for example, if we wanted to be able to move this polygon, I might want to add 2 parameters here to my function. Maybe let's call them X and Y. Okay? Now, what we might want to use these parameters for, well, instead of translating to the center, why don't we translate to whatever X is and Y is? Okay? So this will mean that now this polygon function doesn't have to always draw a polygon in the center of the screen. It will draw it at wherever X and Y are. Okay. Now, obviously, if I add parameters and I try to run it, okay, I'm going to run into a little bit of trouble. This here is giving me an error that is not related to my function, but it's telling me that translate, right, received an empty variable. Okay, so x and y were empty. I've declared parameters here, but I'm not providing any value. So after we declare parameters, we also have to go in Polygon here when we call it and put in some numbers. For example, I could pass mouse x, mouse y. Okay. Now this shape is following my cursor. So what happens when we run this code is we say run the polygon function, and then inside of it we pass mouse x and mouse y. These values get kind of connected in here, right? Now we're inside the function, and now the value of x is mouse x, the value of y is mouse y. Okay? If we were to call this again with maybe like this time I want to center it, okay, I could reuse my function. Now we got to be a little bit careful with this. Something weird is going to happen. I'm going to run the code to show you. Notice now my second polygon is kind of like offset from the first one. Okay? It's no longer following the mouse. That's because inside my function I use a translate, which is fine. It's handy to move the origin in the center of our shape. But remember, transformations are cumulative. They stack. Okay? So if I translate in here and then translate again over here, I have now two active translates that are moving my origin twice. So how do we protect against that? We use push and pop. So at the beginning of my function here, I'm going to say push. So save the origin. Okay. I'm going to push because I know I'm going to translate somewhere. Okay. And before I'm done, I'm going to say pop. Okay. So now this function is going to behave a little bit better. Before it messes around with the origin, it's going to save where it is. Then we can translate or potentially do all kinds of other things here. And when the function is done, we're going to use pop to go back to bring the origin the way we found it at the beginning. So now this works as expected. That's a good idea generally when you design functions in your program, to think about, making sure these functions don't have too much impact outside of their little world. Okay, you kind of want functions to behave in a bubble a little bit. The more impact they have on the rest of the program, the harder it becomes to troubleshoot or find bugs down the road that will occur. Okay? So as a rule of thumb, you want to try to make your functions as contained as possible so that they don't really affect whatever else is happening in the code. So when I call circle in P5, for example, I don't have to worry about circle messing something up in my program. I know it's just going to draw a circle. So the same thing is true here of this polygon function. It doesn't rely on some kind of global settings. It's just going to do what it's told based on the parameters. Okay? So it's obviously up to us to design good functions, and how to do this comes with practice, but this is a good thing to keep in mind, right? Try to keep your functions contained to whatever you're putting in, and think about, is my function going to have an impact outside of it on other areas of the program? And if so, maybe try to find a different way to do it. Okay, so this function now is a little bit more useful than it was because we can specify a coordinate. Now, obviously, you can kind of see where this is going to go. It would be nice if we could have different radius for these polygons, right? So why don't we do that? We're going to specify a radius here. And instead of having to declare this variable over here, now we don't have to do that. This is going to come through the parameter. So I'm going to delete this line. Okay, goodbye radius. And now I've added a third parameter, which means up here, I'm going to have to specify what radius I'm interested in. Let's make the one that's center over here, let's make it 100 pixels. And this one, let's make it 200 pixels. Okay. So now I have three parameters to my function. First two are the coordinates, and the next one is the radius. Okay, just like we do with circle. Okay. Now circle takes a diameter. This takes a radius, right? Different. It might be nice just to be consistent with the other P5 functions that always take a diameter. What if we wanted this to be diameter instead? Okay. Well, we could then just say, okay, radius is simply half the diameter. So this allows me now to think in terms of diameter instead of radius. Again, not a big deal. Okay. Not a big deal, but this is just a good idea because now I'm a little bit more consistent with circle. So if I try to mix my polygons with circles in my program, now I just have to think about diameters, not a mixture of radius and diameter. Okay? Doesn't matter. It's up to us. We're the boss of our functions, just like we're the boss of our variables. We decide what we put into it, and whatever serves the purpose we're trying to accomplish with this code is fair game. And then finally, the last thing that could be nice to add to this function is the number of sides, right? Because we've taken the time to make this flexible, it doesn't make sense to only have a polygon that can only ever have 5 sides. Let's get rid of this and let's make this a parameter as well, so that perhaps now we can have this one have 5 sides and then this one have 8. You know, this one is an octagon now. So the same function now is drawing, you know, 2 different shapes, but both of them share the same logic, the same idea, which is translate to the, move the origin to the, wherever it's going to be the middle of that shape, right? Calculate a radius and then repeat for a number of times based on number of sides, each time calculating a point along a circle, and then connect those dots with a line using beginShape and endShape. Okay? So this is now a very useful kind of general reusable function. Okay, we can now use this function in other programs where we could copy and paste this block, bring it into any other code that we write, and now we have the ability to create these polygons, you know, which, you know, could be a square, for example, right? This one is a little bit rotated because of the way we do our calculation, but could be any other kind of shape. So we've created a useful function that has some parameters, and these parameters influence what happens inside the function. Okay, they allow us to customize the outcome. In this case, we customize this shape. Okay, but we could imagine creating functions for not just geometric shapes, any kind of patterns you can imagine. Right? You might have a maybe you're writing some code that draws some flowers, right? And you want to have some variations, but following a similar structure, right? Maybe different number of petals, different size of like the center and so forth. You could create a function that draws a flower with some parameters, or any other kind of object or shape that you might want to imagine, and then have a little bit of reusable code that you can then build on to create multiple objects or multiple shapes very easily. Now we can simply, one line of code allows us to run all these lines of code at once. Okay? And this is obviously, you know, we can do this as many times as we'd like. For example, in setup, let's try all kinds of different polygons. I'm going to draw randomly, right? Random diameters and random number of sides. Now, before we do number of sides, actually, let me backtrack here for a second. All right, I'm going to put that idea on hold just for a minute. Sorry, I'm just going to rewind here for a little bit. One thing I also wanted to talk about before we do that is we are going to talk about default values. Okay, so this could be useful. For example, if I wanted to make the default number of sides of this polygon equal to something, I could put an equal 5 here, right, in the function parameter, and that would allow me essentially to not provide the fourth parameter. Okay, so now I could do this, and I will get 5. Okay, or if I do provide a value, I can override that default, and now I can have 8. Okay, so this is something that you can do with functions that could be useful. You can provide default values. Just be aware that the default values usually have to be at the end of the list, right? So if you put a number of defaults, they have to be at the end. You can imagine you can't sort of selectively skip some, right? So if one parameter has a default value, it's probably going to be the last one so that it can be omitted if you want to use the default. So little parenthesis here about default values. Let's put a comment so we remember what that is. So xy is the coordinate, right? Diameter, size, and then number of sides, vertices, and then the default equals 5. Yeah? Okay, so back up here, let's try just to write, some code that's going to draw 50 random polygons. So let's, rather than what I was doing before, which was leading me down a path of confusion, let's just spell it out here. We're going to create some random variables. Random height, the diameter, right? We're going to give it a range. I'm just making this up here. And then the number of sides, we're going to make this random between 3 and 12. Okay. Polygon. Let's see what happens if we do that. There might be an issue with number of sides because number of sides should be an integer. Okay, so this should be an integer here. It doesn't make sense to have 4.5 sides. Okay, but let's see what happens. And let's get rid of, let's get rid of the background. Okay, so it kind of works. It creates some really strange looking shapes though, like this one over here. And again, that's because number of sides here is not always an integer. It could be a floating point number. So one thing that we could do over here is we could make sure this is an integer by using the int function. Okay, so if you want to convert a random number into an integer, you can use the int function. All right, so this is looking a little bit more regular. Cool. Yeah, so again, we're just reusing the same function here, just randomizing the parameters just to demonstrate that our function is customizable and can have different outcomes based on whatever values we provide as the input. So a good metaphor to, in conclusion, a good metaphor to use for functions is you can think of them as like a black box, okay? And that black box can have some inputs, right? And then it's going to run some code and then do a job in the program. It is a black box conceptually, but then because we are writing the program here, it can be a black box. For example, resize canvas, right? We don't know what it does unless we go on GitHub and look at the source code for P5.js. We just say resize canvas. Here I'm giving you 2 parameters and then do a thing, do a job in the program. When it comes to functions that we write ourselves, obviously we get access to see what's inside the box because we're the ones putting the code in there. But then once we've written it, we can kind of treat it the same as the other functions, right? They become these reusable components that we can then leverage to build more interesting programs and do more with less. Once we've written the code for a function once, we can reuse that code over and over throughout a bigger program. And that allows us to kind of scaffold complexity over time. Okay? So function parameters are really, really useful. Most functions are going to want to have parameters unless you're only using the function to sort of section out your code and give different labels to different sections of your code. You're only going to use it once. If you use it more than once, you probably should think about, what are some things that could be nice to customize about what happens inside the function, and then you can kind of expose those as parameters using this syntax. Okay. All right. So we're going to leave it at that for this demo. We're going to do one more example this week where we're going to talk about functions that can have return values, and we'll build a little example around that. I'll see you in the next video.